Good afternoon, class. Here's the final exam review covering all four modules: trigonometric functions, identities, equations, applications, periodic functions, polar coordinates, and vectors. So the final exam is a comprehensive exam. So all we have to do, study all the modules, and we'll be in good shape. So answer the following. Name the quadrant that contains t equals 2. Reminding everyone of a few things. So you have a unit circle here. P has coordinates x, comma, y. And you have an arc. The end of the arc has coordinates x, comma, y. So this is 0. This is 90 or 90 degrees or pi over 2. 180 degrees or pi. 270 degrees or 3 pi over 2. And again, as far as the unit circle is concerned, x squared plus y squared equals 1. Sine represents the y, cosine represents the x, and tangent is the ratio of sine over cosine, or simply y over x. And in general, if you don't have a unit circle, you have a circle in general, x squared plus y squared equals r squared, then tan is y over x, sine over cosine, and so on and so forth. These are reciprocal identities everybody is familiar with by now. Now, pi over 2 is roughly 1.7, pi is 3.14, 3 pi over 2 is 4.71, and 2 pi is roughly 6.28. Therefore, if you look at the first quadrant, t is between these two numbers, 0 and pi over 2, which is about 1.7. In the second quadrant, between 1.7 and 3.14. In the third quadrant, between 3.14 and 4.71. And in the fourth quadrant, between 4.71 and 6.28. Therefore, the answer is clearly, because 2 is in between these two, quadrant 2. Cosecant of 11 pi over 2, we can take off 8 pi over 2. It's, remember, all trigonometric functions or periodic functions. You can take multiples of 2 pi for all of them. In the case of a tangent and cotangent, just multiples of pi will do. So in essence, this is cosecant of 3 pi over 2, or 1 over sine of 3 pi over 2. In this case, you really don't need a reference arc, but the reference arc is pi over 2. So sine of pi over 2 is a positive 1, 3 pi over 2 is negative 1, and therefore the answer is negative 1. So this is as basic as it gets. If the length of an arc is 50 inches in a circle with a radius of 6 inches, find the angle theta this arc subtends. And reminding everyone of a couple of formulas. Omega is theta over t, or 2 pi times RPM. This is the angular velocity. V is s over t, or omega, s equals r theta. A is 1/2 r squared theta. So we are looking at the arc length, s equals r theta. And so what is given? Given comes s is equal to 50 inches, and the radius r is 6. So we are looking for theta, therefore s equals r theta is used. Theta is s over r, so the ratio of 50 to 6 is 25/3. Precise answer, and it's in radians. Find the area of a sector. A is half of r squared theta, and so half of r, 6 squared. And theta, we found it to be 25/3. And one of those 6 cancels out 2 times 3, so 6 times 25 is 150 inch squared. Find the linear velocity of an object on the rim of this circle if it is spinning at 40 RPM. RPM is revolutions per minute, or RPS, revolutions per second. So how many revolutions? A complete revolution is 2 pi. So if we have 40 of them, then it's the product of the two. So given r equals 6 inches, omega is 40 RPM, and then velocity. So omega is 2 pi times RPM, 2 pi times 40, or 80 pi. radians per minute. V is R omega. R is 6 and omega is 80 pi. So we get precisely 480 pi or 1,507.96 inches per minute. We want to simplify sine squared plus cotangent squared plus cosine squared, reminding you of various fundamental identities, whether it's Pythagorean identities, quotient identities, or reciprocal identities. Those are extremely important for us to know. So we don't have to move it, but let's move sine squared and cosine squared next to each other so everybody can see these two. Of course, they add up to 1, and 1 plus cotangent squared is cosecant squared, and we're done. What about cosine of pi over 6 and secant of 13 pi over 6? Reminding you that every trigonometric function is periodic, and the period is 2k pi, except tangent is just k pi, and therefore k times pi. So the period is 2 pi for all of them. For tangent and cotangent is just pi, and k is some integer. So this one is larger than 2 pi because it's 12 pi over 6 plus pi over 6. And again, 12 pi over 6 equals 2 pi. So you subtract 2 pi in essence. You subtract 2 pi. Now, secant is 1 over cosine, so these two cancel each other. The answer is 1. What about cotangent? We said tangent and cotangent, the period is pi or k pi in this case. So cotangent of theta minus pi or plus pi or minus 2 pi or plus 2 pi makes no difference. Both of them are cotangent theta. So we have 3 of those, and we're done. Find the amplitude, period, intercepts, and phase shift for the function, and sketch it. Y equals minus 6 sine of pi over 3x plus 4. And this is one format to have this in general. So obviously, this is the amplitude. So the absolute value of this becomes the amplitude, which is 6. T is 2 pi over omega, or 2 pi over b. So you are going to divide the 2 pi by pi over 3. And that becomes 6. Phase shift, we don't have any. So we are going to cut this into 4 equal parts. So we're going to divide the t into 4 equal parts. We get 3 halves. And we start with the phase shift. There's no phase shift, so we start from 0. So 0 to 3 halves. The next one is 3 halves to just add 3 halves. Becomes 3. The next one is 3 to now add 3 halves, 9 halves, and so forth. So I hope you see that 0 to 3 halves, and then keep on adding 3 halves. And those are the end points. So let's look at a pair here. And we are going to look at this one first, okay? So never mind this plus 4. And by the way, we are going to look at the endpoints. 0, 3 halves is the same as 1.5. 3, 9 halves is the same as 4.5, or just write 9 halves, and 6. So if we plug in 0, as you know, sine of 0 is 0, therefore minus 6 times 0 is 0. If I put 1.5, just for the sake of argument, so if I put 1.5, I get minus 6 sine of power 2. So sine of power 2 is 1, so I get minus 6. If I put 3, I get minus 6 sine pi. which is 0 because sine pi is 0. And I'm going to assume you can figure out the rest of it accordingly. So let me erase my. So let's plot those three, 0, 0. So let's say, so 0, 0, and then we have 1, 2, 3, 0, and then 4, 5, 6, 0. So those are the 3 points. Now the other two, 1.5, this is 1, this is 2, 1.5 is here, and go down by 6. And then 4.5, so this is 3, this is 6 in between, and go up, okay, by 6. And that's a complete cycle. However, this is not the function. The function is this one, plus 4. That means there is a vertical shift. And so we move it up by 4 units. Y equals 4, which has the name, by the way, the midline as well. And so basically you move it up by 4. So what happens is that now all of this correspond to 4 more. So this becomes 4 minus 2, 4, 10, 4, and those are the new points. That's one complete cycle moved up by 4. And of course, this is one complete cycle. You can continue indefinitely on both sides if they ask you. We want to graph this function now. Of course, we want to come up with the amplitude and everything. So first and foremost, when you have a function in this format, you want to put it in this format by taking number 3 out. If I take the 3 out, this becomes x. If I take the 3 out, I have to divide. In other words, divide this one by 3, you get x. This one by 3, you get power over 6. That's the first thing you want to do. So what is the amplitude? 2. So the absolute value of 2. What is t? 2 pi over omega or 2 pi over b? 2 pi over 3. What is the phase shift? Minus pi over 6, according to this, right? So we're going to cut the period, okay, into 4 equal parts. So 2 pi over 3 divided by 4 becomes pi over 6. Now, we have to start from the phase shift, and we add. First, we add the period, which is 2 pi over 3. So we see that it goes from minus pi over 6 to pi over 2, because this one is 4 pi over 6 class. Everybody knows that, right? 4 pi over 6 added to negative pi over 6 is 3 pi over 6, which is pi over 2. And so what are the endpoints? We start with the very first one, minus pi over 6. And then we add this number, okay, right? Because we cut it into 4. So minus pi over 6 to 0. Then 0 to pi over 6, right? And pi over 6, add pi over 6 becomes pi over 3. Then pi over 3 to pi over 2. I hope everybody is comfortable with those 4 parts after minus pi over 6. So the endpoints are minus pi over 6, 0, pi over 6, pi over 3, and pi over 2. So let's write them. And so let's evaluate them, starting with negative pi over 6. And it seems that it's easier here. If I put the negative pi over 6 here, I get 0. Cosine of 0, 1 times 2. This is 2. If I put 0, this goes away. 3 pi over 6 is pi over 2. Cosine of pi over 2 is 0 times any number is 0. Okay. I do one more. If I put pi over 6 and pi over 6 is 2 pi over 6, okay, or 2 pi over 3 times 2 is 2 pi. Okay. And 3 times that makes it 2 pi cosine is 1, and we get for pi over 6 and pi over 6, we get 2 pi over 6 times 3, which is going to give us -2. If I put pi over 3 with pi over 6, I get pi over 2. 3 times that is 3 pi over 2. 3 pi over 2 cosine is 0, and so on. So we get those points. So minus pi over 6 corresponds to 0, 0 corresponds to 0, pi over 6 to -2. And so we plot minus pi over 6. Okay, so roughly, just to give you an idea, from 0 to minus pi over 2, we cut it into 3 parts. So the first part would be minus pi over 6. 0, 0 is here. Pi over 6 between 0 and pi over 2 go 1/3 of the way, and it's -2. And then pi over 3 is somewhere there. And then pi over 2 corresponds to 2. And that's the graph. Now, this is a complete cycle, but in case you want to continue indefinitely, you would get this one, okay? Just so we have both of them in case, okay? By the way, I think I mentioned pi over 6 gives you 2 pi over 6 times 3, 6 pi over 6, which is pi. Cosine of pi is -1 times 2. I think I mentioned that. I'm not too sure. Excuse me. Anyways, we want to find the exact value, tan inverse of tan of -2 pi over 3, and we want to see how this thing is going to play out. Let's remind everybody of a few things. Remember, trigonometric functions, none of them is 1-to-1, so you cut the domain so it becomes 1-to-1, and it has an inverse. For example, for sine, we cut it between -pi over 2 and pi over 2. That means in the first and fourth quadrant. Then it has an inverse. For tan, we do the same thing. Of course, the endpoints are not included. Cosine, we cut it between 0 and pi. The endpoints are included. Cosecant basically follows the sign, so cosecant inverse, and of course, y can't be 0. Secant follows cosine, and of course, y can't be pi over 2. Cotangent, in essence, some might expect it to follow tan, but it doesn't. It follows, in essence, cosine, and of course, the endpoints are not included. So having said that, and of course, again, reminding everybody, in the first quadrant, every trigonometric function is positive. In the second quadrant, sine is positive, which means it's reciprocal. Cosecant is also positive. The rest are negative. In this case, third quadrant, tan and cotangent are both positive. In this case, cosine, and therefore its reciprocal secant are positive. The rest are negative. So tan of -2 pi over 3. Okay, so we go this way. Okay. And it puts us in the third quadrant. When it puts us in the third quadrant, it's the same as tan of pi over 3. So it becomes tan inverse of pi over 3, which is square root of 3. And the answer is pi over 3. So that actually indicates pi over 3. What I want to make a point of, you can't say they undo each other and they give you -2 pi over 3 unless it's in the proper domain. In this case, it has to belong to the domain of tangent, okay? And as far as tangent is concerned, the domain of tangent is -pi over 2 to pi over 2. So therefore, that's not going to be the answer. We want secant inverse of square root of 2. We don't know what that is. Let's call it alpha, beta, gamma, x. By definition of an inverse function, then secant of alpha must be square root of 2. And again, we may not know secant, so cosine is the reciprocal of that. 1 over square root of 2 or square root of 2 over 2, and then alpha becomes pi over 4. What about cosine inverse? Again, the same thing. Let's set it equal to something, for example, theta. By definition, cosine theta becomes 1/2, and it's a common arc. Theta is pi over 3. What about tan of cosine inverse of square root of 3 over 2? Cosine inverse of square root of 3 over 2 is missing. Let's give it a name, beta, anything. By definition, cosine beta is square root of 3 over 2. That's a common arc, and beta becomes pi over 6. So we are looking at tan of pi over 6, and we know it to be square root of 3 over 3. A cosine of inverse of 1.2, that doesn't exist, is undefined because 1.2 is larger than 1. That's why. Because this belongs to the domain of cosine inverse, or range of cosine, which is -1 to 1. Okay? So cosine of cosine inverse of x is x if x is between -1 and 1. Remember, cosine can't be larger than 1 or smaller than -1. You want to write trigonometric expression for sine of tan inverse of u. The trigonometric expression for that, we let this one be something alpha, beta, gamma, theta. By definition, tan theta becomes u, and we are looking for sine theta. And reminding everybody, we have Pythagorean identities, quadrants, and what's going on. So there are two different ways of approaching them. Let's quickly do so. So if tan theta is u, then cotangent theta is 1 over u. And we can find sine theta using identities. We know that one of the Pythagorean identities says 1 plus cotangent squared is cosecant squared. So replace the cotangent with 1 over u. You get 1 over u squared. And so if I take a common denominator is u squared, so this becomes u squared plus 1. Now cosecant, we know it to be 1 over sine. So if cosecant squared is this, sine squared is the reciprocal of that. So sine squared is the reciprocal of this u squared over 1 plus u squared, which makes sine plus minus that, the square root. And we just take the positive. And the reason we do, because sine and tan have the same sign, because the limitation that we put on the inverse functions for sine and cosine are the same, with the difference that for tangent, the endpoints are not included. That's the only difference. But both of them give us the fourth quadrant and the first quadrant. We can look at it from the point of view of a triangle. Tan theta by definition is opposite over adjacent. And so as we look at this one, if we go back to tangent, we said tangent is u or u over 1. Let's make it u over 1. So if this is theta, the opposite is u and the adjacent is 1. So if I want sine, the sine is the opposite over the hypotenuse. So I need to calculate the hypotenuse, which is 1 squared plus u squared under the radical. And now I have my sine opposite over hypotenuse. And in this case, it happened to be working faster. Use the half angle formulas to give exact values. No calculated. It's a sine of 195 degrees. So we know 195 is half of what angle? 390 degrees. And 390 degrees is 360 plus 30. And therefore, it's really the same as 30. And it's a common arc. So that's why we go with that. Okay. So with that being the case, the sine would be plus minus the square root of 1 minus cosine alpha over 2. So plus minus 1 minus cosine of 390 degrees over 2. Now, 390 degrees over 2 or 195 degrees, I hope you know, it's more than 180 degrees, puts us in the third quadrant, and therefore we use the negative. In the third quadrant, sign is negative, so we use the negative. You have to figure out the sign on your own by looking at the quadrant, in the third quadrant, okay? Now, 30 degrees, common arc, cosine is square root of 3 over 2, and if you multiply the top and the bottom by 2, this is 4, comes out as 2, and this one times this one is 2, this one times this one is minus square root of 3. So square root of 2 minus square root of 3 over 2 is the exact answer. What about 15? First and foremost, first quadrant is positive cosine of 30 over 2. And cosine of alpha over 2 is plus minus the square root of 1 plus cosine alpha over 2. However, we use the positive because we know 15 degrees, it's in the first quadrant. So we use the positive, and cosine of 30 is obviously square root of 3 over 2. In essence, becomes very similar to that. You multiply it. Let me erase my work. If you multiply the top and the bottom by 2, you get this one with the plus sign, everybody. So you're gonna and the exact answer is square root of 2 plus the square root of 3 inside that, divided by 2. We're going to move on, but I highly recommend you try cosine of 15 is equal to cosine of 45 minus 30. Use that one, the difference of angles. All right, we want to prove the identity. Cosine of power 2 plus x is the same as negative sine x. We want to prove that. Okay, so we always start with the side that is more complicated, in this case, the left-hand side. And we write cosine of power 2 plus x, and we follow the cosine of alpha plus beta, cosine alpha, cosine beta minus sine alpha, sine beta. So this is cosine of power 2 cosine x minus sine power 2 sine x. We replace the cosine power 2 with 0, sine power 2 with 1, and obviously this goes to 0. This becomes negative sine x, and that's a proof. What about tan theta over secant theta equals sine theta? Again, we start with one side. Let's go with the left-hand side. And all we have to do is change them as a function of sine and cosine. As you know, tangent is sine over cosine, secant is 1 over cosine. And basically, you can drop the cosine, or you say, I'm going to multiply by cosine over cosine because it's a complex fraction. This cancels this one, you get sine theta. This cancels this one, you get 1. And the final answer is sine theta, which is the right-hand side. Find the exact value, 2 sine power 8 cosine power 8. We recognize this as the sine of double angle. Sine of 2 alpha is 2 sine alpha cosine alpha. So this is sine of 2 times power 8, which is sine of power 4, and therefore square root of 2 over 2. This, exactly the same concept. It's sine of 2 times 45 degrees, which is sine of 90 degrees, which is 1. Sine of 7 pi over 12. Well, we should recognize this as cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, because this is 3 pi over 12 plus 4 pi over 12. 3 pi over 12 is a common arc pi over 4, and this is pi over 3. So we're going to use those. So according to this, we have cosine of pi over 4 cosine pi over 3 minus sine pi over 4 sine pi over 3. Common arc, so cosine of power 4 as well as sine of power 4 are replaced with square root of 2 over 2. Cosine of power 3 is 1/2. Sine of power 3 is square root of 3 over 2. They all have the denominator 4. This is square root of 2 times 1. This is square root of 2 times square root of 3, which is square root of 6. So square root of 2 minus square root of 6 over 4 is the final answer. Find the exact value of the expression and justify. So cosine of pi over 2, 12, cosine of pi power 12 plus sine of pi over 12, sine of pi power 12. I hope you quickly recognize this as, excuse me, cosine of alpha minus beta, okay, which is cosine alpha cosine beta plus sine alpha sine beta. Therefore, cosine of power 12 minus 5 power 12, which is cosine of negative 4 power 12. Now, negative 4 power 12 is negative power 3, and cosine is an even function, is the same as cosine of power 3. Remember, cosine of minus theta is cosine of theta. That's what. It's an even function, which is 1/2. What about 105? 105 is the sum of 60 and 45, so we make it cosine of 60 and 45, and we use cosine of alpha plus beta. So cosine alpha cosine beta, that means cosine 60 cosine 45 minus sine 60 sine 45. Common of cosine is 1/2, plus sine of 45 is square root of 2 over 2, minus sine of 60 is square root of 3 over 2, and this is square root of 2 over 2, common arcs. This is square root of 2 minus square root of 6, and the denominator is a common denominator of 4. We want to establish the identity tan theta plus cosine over 1 plus sine is secant theta. Obviously, the more complicated side is the left-hand side. So we start with the left-hand side. We are going to change the tan to sine over cosine. And if we take a common denominator, we get cosine times 1 plus sine theta. That is the common denominator, the product of the two. And of course, this is sine theta times 1 plus sine theta, and this is cosine theta times cosine theta. So sine theta times 1 is sine theta times sine theta is sine squared, cosine theta times cosine theta is cosine squared. I'm assuming no one has any problem adding two fractions. Clearly, sine squared and cosine squared, they add up to 1. So now we have sine theta plus 1 in the numerator, which is identical to 1 plus sine theta. They cancel each other. We get 1 over cosine theta, which is secant theta, and that's the proof. Sine of 3 theta over sine theta minus cosine 3 theta over cosine theta equals 2. Obviously, the left-hand side is the more complicated side. So we go with the common denominator, which is the product of these two. So if I put this as a common denominator, sine theta, cosine theta, this one I have to multiply by this one. And minus this one, I got to multiply by this one. And I get sine 3 theta, cosine theta, minus cosine 3 theta, sine theta. And we quickly recognize the numerator as sine of alpha minus beta, which is sine alpha cosine beta minus cosine alpha sine beta. So sine of alpha cosine beta. So right here, this is sine of 3 theta minus theta. Sine theta cosine theta, you know sine of double angle is 2 sine alpha cosine alpha. So if I had a 2 here, this would be sine of double angle. So I'm going to put a 2 and a 1/2 next to it so it becomes clear. So the top is sine of 3 theta minus theta. The bottom, I'm going to put a 1/2 and 2. As you can see, the top becomes sine of 2 theta. And this is the sine of 2 theta also. And the 1/2 makes it half. So we have 1 over 1/2, which is 2, because these two cancel each other. One over 1/2 is 2, just in case. Solve equations. Cosine squared minus sine squared plus sine x is 0, and we want it to be between 0 and 2 pi. After you find that, if you want all solutions, just add 2k pi for each case. So we have cosine squared, we have sine squared, and we have sine. When you have cosine squared as well as sine squared, you can use the first Pythagorean identity, sine squared plus cosine squared, to change them to one of them. Which one do you change it to? Because we have sine x, we're going to keep this one, and we're going to change this one to 1 minus sine squared. So we are looking at 1 minus 2 sine squared. And to factor this, we are going to move this or make everything, multiply everything by -1 and put this in descending order. If you multiply by -1, this is positive 2 sine squared x. This is negative, this is negative. However you want to put that. And the reason I do that, because I want you to be clear as to how we factor this. Clearly, this is a prime number, so you need 2 sine x and sine x. And then this is -1, so it's just 1 and -1. You have to put it in a format that the middle term works. So when you put +1 -1, notice this is sine, this is -2 sine, they must add up to negative sine. Also, if you for any reason find it difficult to do so, then let sine be something other than x, okay? Let's say it's y. Therefore, this is 2 y squared minus y minus 1 equals. Factor this one and then change the y. Whatever is easier. All right. So either this one is 0 or that one. This is 0, sine x is -1/2. This is 0, sine x is 1. So first, I want to remind you, if you want to solve a trigonometric which is negative, first look at the positive so you can figure out the reference arc. So I want to quickly show you in case it's, let me erase the board, in case you find it a little bit difficult. First say, okay, sine x equals 1/2, x is pi over 6, and this one is x sub r, the reference arc, okay? Because it's -1/2, negative is in the third and fourth quadrant. In the third quadrant, we add this to pi, we get 7 pi over 6. In the fourth quadrant, we subtract this from 2 pi, we get 11 pi over 6. Now, sine x equals 1, it's pi over 2. Now, and if they said, if they didn't give us this one, we want all solution, we got to add plus 2k pi to all those three. I'm going to solve this equation. Again, if you want, you can write this as, let's say this is y. So you can write this as 2y squared minus y minus 1 and do the factoring, but it's not a big deal. Just the way it is 2 cosine theta plus 1 cosine theta minus 1. I hope everybody's comfortable with that. So either the first one is 0 or the second one, which results in cosine theta being -1/2, cosine theta being +1. Well, +1 is simple, theta is 0. But I want to discuss this again with the reference arc. So you look at cosine theta equals +1/2, and the reference arc is pi over 3, reference arc. So that means -1/2, okay? The reference arc is that. You know that cosine is negative in the second and third quadrant. In the second quadrant, you subtract this. Remember, that's how it works. Theta prime is pi minus theta. So theta is pi minus theta prime. Okay, theta prime or theta sub r, there are different ways of writing the reference arc. So pi minus this and pi plus this in the fourth quadrant, okay? And then my apologies, third quadrant, okay? Because cosine is negative in the second and the third quadrant. So pi minus pi over 3. Second quadrant is 2 pi over 3. Pi plus pi over 3 is 4 pi over 3. And as I mentioned, this is 0, and that's the list. Very straightforward. Sine of 3 theta is 1/2. How do we handle multiple angles? First, assume it's x and go with x, and then we'll discuss the multiple angles. So if sine x is 1/2, okay, we know sine is positive in the first quadrant, pi over 6. And second quadrant, pi minus pi over 6, which makes it 5 pi over 6. And we are letting x represent 3 theta. And we're going to come to that and how we arrive at it. Now, 3 theta is pi over 6. How do we handle this from 0 to 2 pi? We write 3 theta is pi over 6 plus 2n pi or 2k pi. And then in order to get to theta, okay, you have to divide by 3. This becomes pi over 18. This becomes 2n pi over 3. For 5 pi over 6, we're going to again do the same thing, and we're going to put plus 2k pi or plus 2n pi. And if I divide by 3, this becomes 5 pi over 18. This becomes 2n pi over 3. And you let n be 0, 1, 2. And you stop. In other words, whatever this number is, subtract 1. Why don't you let it be 3? Let's just try number 3. If I replace the n with 3, this cancels out the 3, and I get 2 pi. So it goes beyond a complete revolution. So if I put number 3, this becomes 2 pi. So for example, if I put 0, of course, pi over 8. If I put 1, and let me change that such that the denominator is 18, so 12 n pi. Okay. Okay, this piece, same thing here, 12 n pi over 18, so we can easily see what's happening. So 0 is pi over 18. If I put 1, I get 12 and 1, 13 pi over 18. If I put 2, 2 times 12, 24 and 1, 25 pi over 18. Now let's try it here. If I put 0, I put 5 pi over 18. If n is 1, 12 and 5, 17 pi over 18. If n is 2, 24 and 5, 29 pi over 18. And again, if you go beyond that and you put 3, it goes over the complete revolution. And we're done. And of course, if they say find all solutions, for each one you add 2n pi. We want to solve a right triangle where AB, 2 sides, and the angle, of course, it's a right triangle, is 90 degrees. So reminding everyone that in the case of a right triangle, Pythagorean theorem says a squared plus b squared equals c squared. Sine is the opposite a over c sine of a, opposite a over c, and sine of b is opposite b over c. Cosine a is the adjacent b over c, and cosine b is the adjacent a over c. That's why sine a and cosine b are the same. Sine b and cosine a are the same. Tangent a is a over b, tangent b is b over a, so on and so forth. And so if that is the case, let's just put in the information. And obviously, Pythagorean theorem, a squared plus b squared equals c squared. We get 68. So c squared of 68, which is 4 times 17. 4 comes out as 2. And the precise answer is 2 squared of 70, roughly 8.20. So we have all sides. What about the angles? Let's pick up one of the angles. For example, because A and B are given, don't use sine and cosine, rather use tangent, which is tan of A, tan of B equals B over A. 2 over 8, 1/4. So B must be tan inverse of 1/4. not a common arc. You have to use a calculator, and we end up with 0.25 radians or 14.03 degrees. Subtracted from 90, we get the last angle, and we write all of it. Again, bear in mind, this is exact, this is an approximation, and you always pay attention to the way they want you to answer it. A balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram. By the way, this one, even if they don't say so, to me, I have no idea how you can come up with the answer without drawing. So the drawing plays a huge part. And of course, a piece of information is that 1 mile is 5,280 feet. Reminding everyone, this is the horizontal plane or line, and if you look up is the angle of elevation, looking down is the angle of depression. So angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. Angle of depression is the angle formed by the line of sight and horizontal plane for an object below the horizontal. So that's something we should know. I wanted to remind you that. So if we were to draw the setting, here's the balloon, and here's 600 feet above, and the airport is at the distance of 5 miles. This angle is the angle of depression, which we call it theta, and it's missing in action. We are looking to find that. So this angle is identical to this one. We've already discussed that. The concept is because of alternate interior angles are equal. And so basically, you're going to find this one by saying the easy way out, tan of theta is the opposite 600 over the adjacent 5 miles. 600 feet over 5 miles. It's important to have the same units. So this one, you're going to multiply by 5280. Now they are both in feet. So they cancel each other, the units. And so you put it into a calculator, you get 0.022772, and theta is the tan inverse of this number. And when you go with the calculator, this is what you get. And if you want to stop at some point, for example, if I want to stop here, next to it is 9, so I'm going to change it to 2, and I'm going to say 1.302 degrees. It's important to know why we stopped there. At some point, you have to stop, and that is pretty straightforward. An aircraft is spotted by 2 observers who are 1,000 feet apart. As the airplane passes over the line joining them, okay, each observer takes a siding of angle of elevation to the plane as indicated in the figure. So each one comes up with their own angle. This one is 35 degrees. This is 40 degrees. So this is H, this is Y. We give it some names. And we say this angle P or Q is 105 degrees. The question is why? Let me quickly justify it. If you look at this one, for example, this angle and this angle add up to 90 degrees must be 50. If you look at this one, and this one must add up to 90 degrees, that means 55. And the sum of these two is what we are interested in. P RQ is 105 degrees. So in the large triangle, we can use sine law, sine A over A, sine B over B, sine C over C. In this case, this is sine of 105 over 1000. And this is sine of 35 over y, because first we're going to find y, and when we are done in this shaded triangle, I can find h. So first I want to find y. So sine of 35 divided by y. Therefore, y is the product of these two divided by sine of 105. And you just have to put it into a calculator. So y, which is the distance PR, is about 593.81, roughly 594 feet. Now that we have the y, we know that sine of 40 is the opposite h over the hypotenuse y. We are looking at this one, this left side right triangle. And we write sine 40 is h over y, or h over this number that we have. Therefore, h is the product of these two, sine of 40 and 593.81. Their product is 381.69 feet.